Hello student, how are you all? I hope you all are doing good. I am Pooja Tripathi, your teacher. So student, you have read about the square numbers and how to find out cube. So in this chapter, we will learn about the squares and cube. So our learning objective in this chapter are understanding square numbers. What are square numbers? Cubic numbers, square roots and cube roots. So we are going to learn all these things in this chapter. First, we are going to start with understanding square numbers. So what are the square numbers? In everyday situation, we need to calculate the area of the object that are square in shape. You know, we always find area in square. Like a classroom floor tile, a decorative coaster or a small garden section. So in all that we need square. Whenever we multiply the length of the square side by itself, such as doing 4 into 4 or 9 into 9. So what we are doing here, we are multiplying 4 into 4 and 9 into 9. So we are working with what is called the square number. So this is what? Square number. Multiplying the number with the same number or 2 times, that is a square. A square number is the product of obtained when the number is multiplied by itself. Means number is multiplied by itself, that is the square number. For example, 3 multiplied by 3, that is square of 3, that is equals to 9. 7 multiplied by 7, square of 7, that is equals to 49, and 12 multiplied by 12, that means square of 12, that is equals to 144. So in general, n multiplied by n, that is equals to n square, square of n.
Action.
Next is relationship between areas and perfect square. Now we'll understand what is the relationship between area and perfect square. Square numbers are closely related to the concept of area of square. When we find the area of a square whose side length is whole number. Suppose we have to find the area of square and length is whole number. The result is always a perfect square. For example, suppose the sides are given and we have to calculate the area. So side here given is 1 unit. So area 1 multiplied by 1, square of 1, that is equals to 1. If side is 2 unit, area will be 4 unit. If size is 3, area 9, 4, then 16, 6, then 36. Clear? So thus we see that the square of none of the number are ending with 2, 3, 7 or 8. So that the number ending with 2, 3, 7 or 8 are not perfect square numbers. So the numbers which end with 2, 3, 7 and 8, that we have to keep in mind, they are not perfect square. Can a square have a fraction or decimal side length? Yes, the square can have side that are fraction or decimal. For example, the square with the side 5 by unit has an area 5 by 8 multiplied by 5 by 8, that is equals to 25 upon 64. A square with the side 4.5 unit, if the side is 4.5 unit, then the area that is equals to 4.5 multiplied by 4.5, that is 20.25. Note, in this chapter, the term perfect square refer mainly to the square of whole numbers. So if we say the perfect square, mainly we are talking about the whole number like 1, 4, 9, 16, 25 and so on. These are the perfect square number. Next is now suppose we will take example here, find the area of square whose side is 28 centimeters. So side is given to us, we have to find the area. We know the area of square, that is side into side. So 28 into 28, that is equals to 784 centimeters square. Therefore the area of square will be 784 centimeters square. Now we'll see the properties of the square number. So what are the properties of a square number? Square number shows several interesting and predictable patterns. Understanding these patterns help us recognize square quickly and even check whether the number can be perfect square. So these properties help us to check whether the number is a perfect square and their pattern. One of the most useful pattern is called the unit digit rule. So let's see what is this rule. Now the unit digit rule. Look at the table below which shows some numbers and the last digit of their square. So these are some numbers are given. We can see the last unit, like you can see 1, 4, 9, here 6, 5, 6, 9, 4, 1, 2 zeros are there, 4, 6, 4, 4, 6, 1, 4, 5 and 0. So what we have observed in this table, if you observe the unit digit means from right hand side the first digit, the last digit carefully, pattern begin the pair. What pattern do we see? Number ending with 1 and 9, they square and in 1. If the number ending with 1 and 9, you can see the number ending with 1 and 9, then the square end with 1. Suppose the square of 11, if we talk about the square of 11, the number unit place digit is 1, so the square end with 1. Square of 19, that is 361. Clear? So this rule applies here. Now the number ending with 2 or 8, square ends in 4. If the number ends with 2 and 8, so square end with 4. We'll take an example here. The square of 12 is 144, unit digit 4. Square of 18, 324, unit digit 4. If the number is ending 3 or 7, square end at 9. Square will end in 9. Square of 13 is 169, square of 27 is 729. If the number ending with 4 and 6, then the square end in 5. Square of 14, 196. Square of 26, 676. Now the number ending with 5, the square end in 5. Like square of 15 is 225, the unit digit is 5. Number ending with 0, square ends. For example, square of 20, so 0. Now why this is useful? This pattern helps you to predict the unit digit of the square number. This pattern helps us to find out the unit digit of the square number without doing the full multiplication. For example, suppose what is the last digit of square of 47? So square of 7 is 49. So last digit will be 9. What is the last digit of square of 82? The number end with 2, so the square digit end with 4. What is the last digit of square of 95? The number end with 5, so square digit will be 5. So this pattern helps us to find out what will be the unit digit of the square number without doing actual multiplication. Now odd and even square numbers. What we look at the odd and even numbers and important patterns pairs. So what is the pattern? Just as the number themselves can be odd or even, their square follow the clear rule. So what is the rule? The square of any odd number is always odd and the square of any even number is always even. If the number is odd, the square is odd. If the number is even, square will be even. This happened because odd multiplied by odd, that is odd, and even multiplied by even, that is even. For example, 11 is an odd number. For example, 11 is an odd number, so square of 11, 121, that is odd number. 14 is an even number, so square of 14 is 196, that is an even number. So square of odd number is always odd and square of even number is always even. One more example we'll take here. Find the last digit of the square of each number below without actually multiplying. 39, last digit of the number is 9. So number ending in 9 having the square ending with 1. So square of 39 will end with 1. 842. The last digit is 2. So, the number ending with 2 having square ending with 4. Square will end with 4. Now, in this number, the last digit is 3, so square will ending in 9. Now, the difference between square of two consecutive numbers. So, consecutive natural numbers that comes one after another. Consecutive means coming one after another. For example, 6 and 7, 12 and 13, they are consecutive numbers. Let's the two consecutive number be, suppose the first number is n and the second is n plus 1. So, let's find the difference between their square. So, n plus 1 square minus n square. So, that is equals to n square plus 2n plus 1. Now, subtract n square. So, if we subtract n square from this, so we will get 2n plus 1. So, conclusion, the difference between the square of two consecutive natural number is always 2n plus 1, that is 2n plus 1. Where n is the smaller of two numbers, here n is the smaller number. If two numbers are given, n is the smaller number. Clear? Now, we will take an example here. If the two numbers are 10 and 11, suppose these two numbers are 10 and 11. So, we will find out the difference. Square of 11 minus square of 10, that is equals to 21. 121 minus 100, that is equals to 21. Using the formula 2n plus 1, 2 n, that is equals to smaller number, that is 10 plus 1, 21. Both method give the same number. So, we will get the same number 21. Non-perfect square between consecutive perfect square. Perfect squares such as 16, 25, 36, 49. All these are perfect square numbers. They are obtained by squaring whole numbers. The natural numbers that falls between any two consecutive perfect squares are called non-perfect square numbers. These are called non-perfect square numbers. For example, between square of 6 and square of 7. Square of 6 is 36 and square of 7 is 49. So, the number 37, 38 till 48 are non-perfect square. Now, how can we find out this? How many non-perfect square numbers between n square and n plus 1? So, we have to find out, let us two consecutive perfect square be. Suppose the smallest is n square and the largest is n plus 1 square. So, what is the first step? Find the difference between the two square. We will find their difference. N plus 1 square minus n square, that is equals to 2n plus 1. The value tells us how many natural numbers lie between including two squares. Step 2, exclude the perfect square themselves. So, the two square numbers n square and n plus 1 square should not be counted. We will not count n square and n plus 1 whole square. Not be counted as non-perfect square numbers. Therefore, the numbers of non-perfect square between them is 2n. So, that is equals to 2n. Now, we will take an example here. We have to find the difference between the square of 35 and 36 and find how many non-perfect square numbers lies between these two numbers. So, let us the smaller number n, that is equals to 35. N is equals to smaller number. So, here it is 35. Now, we have to find out how many numbers are there, non-perfect square numbers. So, what we will do? Difference between the two square number. Square of 36 minus square of 35. So, that is equals to 71. Number of non-perfect square number, that is equals to 2n. So, 2 into n means 2 into 35, 70. So, the final answer is difference between square of 36 and 35 is 71. So, difference is 71. Number of non-perfect square number is 70. Clear? So, this way we can find out how many non-perfect square number lies between two perfect square numbers. to find whether a number is a perfect square or not. How can we find out whether the given number is a perfect square number or not? Write the prime factorization of the given number. Group the prime factors in such a way. So first we have to do the prime factorization. Then we will arrange them in pair. Both the factors are the same. If no factor is left over after grouping, so we will make the group. If no factor is left over, that means the number is perfect square. Now here some examples are given. Check whether the following are perfect square or not. So we have to check whether 81 is a perfect square or number or not. So we will do the prime factorization of 81. Now we will arrange them in pair. 3 into 3, 3 into 3. So we can arrange them in group. That means 81 is a perfect square number. Clear? So like this you have to practice all the examples. Practice all these examples. Now Pythagorean triplets. So what is Pythagorean triplet? A Pythagorean triplet is a group of 3 positive whole numbers that satisfy Pythagorean theorem, that is a square multiplied by b square, that is equals to c square. Here a and b represent the shorter side of right angle triangle. You know Pythagorean theorem is applied for the right angle triangle only. So a and b are the shorter side and c represent the longest side, that is called hypotenuse. If 3 natural numbers follow these rules, they form the Pythagorean triplets. If 3 numbers follow this rule, means a square multiplied by b square, that should be equal to c square. Then we can say the number are Pythagorean triplets. We will take an example here. Example of common Pythagorean triplets. 3, 4 and 5. So square of 3 is 9, square of 4 is 16. That is equals to 25. That is equals to square of 5. Clear? 5, 12 and 13. So square of 5 plus square of 12, that is equals to 169, that is equals to square of 13. So all these numbers 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24 and 25. These sets of numbers naturally fit the Pythagorean relation. Next is how to generate your own Pythagorean triplets. So the simplest formula can help to create an endless list of Pythagorean triplets for any natural number m that is greater than 1. The number should be greater than 1 for the following form of Pythagorean triplets. Can be written as n square equals to 3k, n square equals to 3k plus 1. So multiple of 3 or 1 more than the multiple of 3. Relationship with 4. Similarly, the square of any number greater than 1 is either exactly divisible by 4, whether it's exactly divisible by 4 or 1 more than the multiple of 4. That is n square equals to 4m or n square equals to 4m plus 1. Now, why does this happen? Why does this happen? Even numbers when square always give the multiple of 4. Even number, when the number is even, when we square it always gives the multiple of 4. For example, square of 6, 36, 4 into 9, that is multiple of 4. Odd numbers when squared always give the value that is 1 more than. If the number is odd, then it will give 1 more than the multiple of both 3 and 4. Square of 7, that is 49, that is equals to 4 into 12 plus 1. These patterns help us to predict and classify square number without doing full multiplication. Now square patterns in repeated digits. When we square number that made entirely of the digit 1, we get the fascinating number pattern. What is this pattern? These results display perfect symmetry, forming beautiful palindromic numbers. So what are palindromic numbers? Numbers that read the same forward and backward. They are palindromic numbers. Look at the example below. square of 11, 121. 111, square of 111, that is 1, 2, 3, 2, 1. Then you will see every time we will increasing 1 in the digit, like 11, 111, then 1111, 11,111. So, square you will see the pattern 121, then 1, 2, 3, then repeating 2, 1, 1, 2, 3, 4, then 3, 2, 1, again reverse 1, 2, 3, 4, 5, 4, 3, 2, 1. Clear? So, notice how each answer grow in the sequence. So, every time there is a sequence 1, 12, 1, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4, and the mirror itself backward, then backward. This creates a number that rise to the peak and then falls in the reverse order. Now, what makes this pattern special? The resulting numbers are palindromes. You will see the resulting number, the number will get our palindromic number, each same as forward and backward. The digit increases step by step from 1 to the middle value. So, you have seen this pattern. Now, the resulting number of palindromic we know, and the digit increase step by step from 1 to the middle value. Clear? Now, after reaching the center digit, the digit decrease in reverse order. So, when we reach at the center digit, the digit started decreasing in reverse order. Each new repeated 1 number creates a longer and the more symmetrical pattern. Now, the visual representation of the perfect square numbers such as 1, 4, 9, 16, 25 can be shown the simple geometrical dot arrangement. When the dots are placed in equal rows and equal columns, they form the square shape, and the total number dots represent the square number, like 1. This is how we can arrange 4 dots, because 4 is square number, 16, 25. So, each pattern make the complete square because the number of dot in each row and each column are same. So, number of dot will be same in each row and each column. Why is this important? It visually explains why these numbers are called square numbers, because we can arrange them in this pattern, square patterns. It helps us to see the perfect square represent the area of the square with the equal side length. It builds a strong connection between the geometry and the arithmetic. So, this is why it is important. Next is learning points 1.1. All these questions are based on the concept we have done in the chapter, so you have to practice all the questions. Next, square roots. In the earlier classes, we have learned how to calculate the area of squares. So, that we have learned when the measure of its side is known. If the side is given, this is done by the multiplying side by side. Side of the length by itself. If we multiply side by side, we will get the area of the square. But sometimes the situation is reversed. The area of square is provided. Sometimes the area is given and we have to work out on the side of the length. So, what will we do in that situation? To do this, we must find the number which when multiplied by itself give the area. Square garden whose area is 81 square unit. So, area is given to us, that is 81 square unit. To determine the length, if we have to find out the length or the side, we need to ask which number multiply by itself to get 81. We know if we multiply 9 by 9 we get 84. Therefore, the length of each side of the garden must be 9 unit. This process of identifying the original number that we used twice. So, the number we have multiplied 9 by 9 to get the square 81. So, the original number was 9, was used twice for the multiplication. This is known as finding of square root. Now, meaning of square root. Square root, the number refer to the value which when multiplied by itself produce the given number. So, if we multiply 9 by 9, we will get 81. So, the number is 9, that is multiplied by itself to get the square number. Symbol, the symbol used for the square root is called the radical sign. This is the sign of square root. For example, square root of 81, that is 9. This tells us that the square root of 81 is 9 because 9 multiplied by 9 gives you the value 81. Here is a table, here the numbers and their square root is given. Like number 1, so square is 1. 4, square root is 2. 9, 3. 16, 4, 25, 5, 36, 6, 49, 7, 64, 8, 81, 9, 110. Now, next is way to find square root. Ways to find square root. How can we find out the square root of numbers? Finding the square root of the smallest perfect square is usually simple because we often remember them from the practice. If we practice, we can easily find out this is the square root and what will be the square of that numbers. We know that the square root of 4, 9 and 16 are 2, 3, 4 because these values are used very frequently. However, when the number becomes large, it is not always easy to guess which value was multiplied by itself to form the number. To handle these cases, mathematics use several systematic methods to determine the square root. One of such methods is the repeated subtraction method. So, let's see what is this repeated subtraction method. You may already know that every perfect square can be expressed as the sum of consecutive odd numbers starting from 1. Let's see example here. Let's look at the example using the number 36. So, 36 that is equals to 1 plus 3 plus consecutive odd number. Sum of consecutive odd number 1 plus 3 plus 5 plus 7 plus 9 plus 11 that is equals to 36. That is the square of 6. Here we added the first 6 odd numbers and the total came out 36, which is the square of 6. Now we use the idea in the reverse. How this method works? To find the square root of the number, start with the given number. Subtract the consecutive odd numbers from it. 1, then 3, then 5, then 7 and so on. Continue subtracting until the value becomes 0. So, we will continue subtracting until the value becomes 0. Count how many subtraction you perform. That count is the square root of number. Let's see how this works. Suppose we want to find the square root of 49. Suppose we have to find out the square root of 49. 49 minus 1, 48. Then we will subtract 3, we will get 45. Then we will subtract 5, we will get 40. Then we will subtract 7, we will get 33. So, we have to keep subtracting until we get 0. So, here we will get 0. So, how many times we have done subtraction? 1, 2, 3, 4, 5, 6, 7. So, we perform 7 subtraction. So, we have performed 7 subtraction. So, square root of 49 is 7. This method works only for the perfect square numbers. Now, finding the square root of the perfect square using the prime factorization method. So, when the number is a perfect square, if the number is a perfect square, it can be expressed as the product of equal pair of prime factorization that we know. The prime factorization method helps us to identify the pair easily and determine the square root. So, using the prime factorization method, we can easily identify and make the pair. Now, to find the square root of a perfect square using the method, to see the example given below. Let's see the steps. Step 1, break the number into prime factors. So, first we will break the number into prime factors. Start dividing the given number by the smallest prime number such as 2, 3, 5, 7, 11 and so on, and continue the process until all the factors you get are the prime numbers, like prime factorization. This gives you the complete prime factorization of a number. Step 2, form pairs of identical prime factors. So, we will make the group of identical prime factors. Since the number is a perfect square, every prime factor will appear an even number of times. So, we will arrange the prime factors into pair and of the same numbers. For example, if your factors include 2's, they form one pair. If there are 4 3's, that make 2 pairs. Step 3, choose one factor from each pair and multiply. So, we will choose one factor from each pair and then we will multiply it. Multiply all these selected numbers together. Clear? The result of this multiplication gives the square root of the original number. Example, find the square root of 1764 using the prime factorization method. So, first we will do the prime factorization. Let us determine the square root of 1764 by prime factorization. So, first we will start dividing the number with the smallest possible prime number, means same as prime factorization. So, the prime factorization is this. So, the prime factorization is 2 into 2 into 3 into 3 into 7 into 7. Pair of 2s 2 into 2, pair of 3 3 into 3 and pair of 7 7 into 7. Since each factor appear in pair, or 1764 is a perfect square. From each pair we will choose one number, so 2 into 3 into 7, that is equals to 42. Therefore, the square root of 1764, that will be 42. Now, solve example. Let's see one example here. Find the square root of the following perfect square. So, we have to find the square root of 784. So, first we will do prime factorization. So, this is the prime factorization, 2 into 2 into 2 into 2 into 7 into 7. So, we will take 1 from each. So, 2 into 7. So, that is equals to 28. Clear? Practice all the examples. So, you have to practice all the examples given here. Next is learning point 1.2. So, all these questions are based on the concept we have done in the chapter. So, all the questions are based on that. That is for your practice. You have to practice all the questions given in the exercise. Next is cubic numbers. Think about playing with small toy blocks and trying to build a big cube using many tiny cubes. So, here using many tiny cubes that make a big cube. For example, suppose you want to construct a cube using 1 centimeter cube block. So, we have to construct a cube using 1 centimeter block. If the side of bigger cube is 3 centimeter, then how many small cubes will you need? 3 into 3 into 3, that is 27. You will require 27 tiny cubes to make the cube of side 3 centimeter. Just the square number help us to find the area of square. Cubic numbers help us to understand the volume of the cube. They help us to understand the volume. Now, what are the cubic numbers? The cubic numbers, also called the perfect cube, obtained when the whole number is multiplied by itself 3 times. If we multiply the whole number by itself 3 times, for example, 1 into 1 into 1, that is 1. So, cube of 1 is 1. 4 into 4 into 4, 64. Cube of 4 is 64. 9 into 9 into 9, 729. So, cube of 9 is 729. In general, for any natural number k, a cube of k, that is equals to k into k into k. This read as k cubed. So, that is equal to cube of k. Next is relation between cube, volume and perfect cube. The table below shows how the volume of the cube related directly to the perfect cube. Like here the side of the cube is given and the volume. So, if side is 1, the volume will be 1. Side is 2, volume is 8. Side is 3, then volume is 27 unit. Side is 4, volume is 64 unit. Side is 5, volume is 125 unit. Now, we will take an example here. The metal cube has a side length of 6 centimeter. What is the volume? So, side is given, we have to find the volume. So, volume, that is equals to side into side into side, 6 into 6 into 6, that is 216 centimeter cube. We always express volume in cubic unit. Clear? So, the metal cube has volume of 216 cubic centimeter. Now, properties of perfect cube. Perfect cube shows several interesting number patterns that make them easier to identify. By observing these patterns, we can often predict the behavior of cube without actually calculating the entire value. So, if we know all these patterns, we can generally predict the behavior of cube, what will be the unit number and all that. Unit digit pattern in the cube. To understand how the last digit behave, look at the cube of the number of 1 to 12. So here you can see the cube of all this number from 1 to 12 is given. You can see the unit digit. Now what will you observe here? Observe the last digit carefully. Pattern we can see. Some number keep the same last digit even after cubing. Like the number ending with 0, 1, 4, 5, 6 and 9 have the cubes with exactly the same unit digit. So their cube unit digit is same as the number. For example, 14. 14 end with 4 and the cube of 14, that is 2744, end with 4. Now 25 end with 5. So and the cube unit digit is also 5. Here 39 end with 9 and the digit of the cube is also end with 9. This helps us to instantly recognize whether the number could be a perfect cube. Next is unit digit 2 and 8 form pair. So if the number end with 2, its cubic end with 8. If number end with 2, cube end with 8. If the number end with 8, the cube end with 2. Example, the cube of 42 end with 8 and cube of 38 end with 2. Now unit digit 3 and 7 also form a pair. A number ending with 3, ending in 3 will have the cube ending in 7. The number ending with 7 will have the cube ending at 3. Example, cube of 13 end with 7 and cube of 27 end with 3. Clear? So these patterns are extremely useful while working with the cubes and cube roots, as they allow us to predict the unit digit of the cube. Now, odd and even cubic numbers. Just as square numbers follow the certain pattern, cubic numbers also shows the predictable behavior. One of the simplest pattern is based on whether the number is odd or even. The cube of every even number is always even, just like square number. The cube of every even number is even and cube of every odd number is always odd. This happens because cubing numbers means multiplying it by itself 3 times for any number n. Cube of n, that is equals to n into n into n. So the cube of the number is n multiplied by n multiplied by n. If n is even, then even multiplied by even multiplied by even, that is even. If n is odd, then that is the cube will be odd. This rule works for all whole numbers no matter how large they are. Example, determine whether the cube of each number will be odd or even without actually calculating the cube. 63 is odd number, so cube will be odd. 244 even number, so cube must be even. 1175 end with 5, so it is an odd number, so cube will be an odd number. This method helps us to quickly identify the nature of the cubic number without performing long multiplication. Clear? Next is patterns of the perfect cube. Perfect cube, much like perfect square, display the beautiful mathematical pattern. These patterns help us to understand how cube grow and how they can be represented in different numerical form. Let us explore 2 important cube patterns. Now we will see some cube patterns. Perfect cube as the sum of the consecutive odd numbers. So you may remember the perfect square can be written as the sum of the first few odd numbers starting from 1 that we have read earlier. Perfect cubes follow the similar idea but with a different twist. The cube of the natural numbers can be written as sum of the many consecutive odd numbers. Let us study the few examples with change digit. Like 1, cube of 1 is 1, 3 plus 5, 8, that is the cube of 2. 7 plus 9 plus 11, that is 27, cube of 3. 13 plus 15 plus 17 plus 19, that is 64, that is cube of 4. 23, 21, 23, 25, 27, 29, 125, that is the cube of 5. So, here you have seen the pattern. This pattern shows that every cube, n cube, is equal to the sum of n consecutive odd number. This is an elegant visual and numerical way to understand. An alternative odd numbers pattern of the cube can also be built using another fascinating sequence of the odd numbers. This sequence does not consist of the consecutive odd numbers, instead it grows in a special pattern. Observe these example, revised pattern. The cube of 1 is 1, the cube of 2, that is 8, 1 plus 7, cube of 3, 27, that is 1 plus 7 plus 19. Then cube of 4, 64, 1 plus 7 plus 19 plus 37. Cube of 5, that is 1 plus 7 plus 19 plus 37 plus 61. So, the number 1, 7, 19, 37 and 61 form the special pattern. The nth term of this sequence is given by, the nth term will find out by 1 plus 3 n minus 1 multiplied by n. This formula produces the correct odd numbers for each position in the sequence. This pattern helps us to see the cube as the sum of odd numbers that increase in wider steps. Now, we will take an example here, express 250 as the sum of the odd number. So, identify the cube equal to 250, we know that. Cube of 6 is 216 and cube of 7 is 343. Since we have to find for 250 and 250 lies between these two numbers. So, choose the new value. Let us express 343, which is the cube of 7, as the sum of odd number instead. Now, step 2. Use the formula for the first odd numbers in the consecutive odd patterns. So, first we will see the pattern starting from the odd number n minus 1 plus 1. So, here n is equal to 7. So, 7 into 6 plus 1, 42 plus 1, 43. Step 3. List 7 consecutive odd numbers starting from the 43. So, that is 7 consecutive odd number, 43 plus 45 plus 47, 49, 50 and 53 and 55. Thus, 343 can be expressed as the sum of 7 consecutive odd numbers. Here you can see. Now, cube of fraction, decimals and negative numbers. How can we calculate the cubes of fraction, decimal and negative numbers? Cubes are not limited to whole number. We can find the cubes of the fraction, decimals and even for negative number we can find out cubes. The basic rule remain the same. The cube of number multiply it by itself 3 times. Suppose we have to find the cubes of a fraction. Finding the cube of fractions were the cube of numerator and the denominator separately. Suppose we have to find out cube of 4 by 9. So, we will find the cube of 4 and 9 separately. So, that is equals to 64 upon 729. Now, cubes of decimal numbers. To cube the decimal number, multiply the decimal by itself twice more, just as you would with the whole numbers. After multiplying, count the decimal place correctly. So, this is how you can find out. For example, cube of 0.5, that is equals to 0.5 multiplied by 0.5 multiplied by 0.5, that is equals to 0.125. Now, cube of negative numbers. The very important rule, the cube of negative number is always negative. So, that we have to keep in mind, the cube of negative number is always negative. This is because the product of 3 negative numbers remain negative. Cube of minus 3, that is equals to minus 27. Now, some solve example, cube of a fraction. Suppose we have to find the cube of 4 by 9. So we'll find the cube of 4, that is 64, and cube of 9, that is 729. So this is the answer. Practice all these examples given here. You have to practice all the examples. Next is learning point 1.3. So all these questions are for your practice. You have to practice all the questions given here. Next is cube root. Have you ever wondered how to determine the side length of the cube when its volume is already known? If volume is then known and we have to find out side, what we have to do? We have to find the cube root. Just the square root help us to find the side of the square from the area. Cube root help us to find the side cube from its volume. Let's understand this with an example. Imagine the solid cube whose volume is given 343 cubic unit. Now we have to find the length. We must look for the number that we multiply by itself 3 times. The result is 343. Since we know that the 7 into 7 into 7, 343, so side of the length must be 7 unit. This method identifying the number was multiplied thrice will get volume, that is known as finding the cube root. Now definition. The cube root of a number is the value which we multiply by itself 3 times recreates its original number. In mathematic form, if cube root of b that is equals to y, so y cube that is equals to b. We use the symbol. This is the symbol for the cube root. Shows the operation. For example, cube root of 27 that is equals to 3, because 3 multiplied by 3 multiplied by 3 that is equals to 27. Cube root of 1000 that is 10. Because 10 multiplied by 10 multiplied by 10, 3 times we will get 1000. Next is method to find cube roots. How can we find out cube root? Just like we have the different techniques of finding square root, there are also several ways to determine the cube root of the number. One of this method used for special pattern found the perfect cube. Let us understand it in simple and clear manner. Finding cube root using the repeated subtraction method. We are using repeated subtraction method. Perfect cube follow the unique pattern. They can be represented as the sum of the certain specially arranged odd numbers. So, now we will see these odd numbers from the sequence such as 1, 7, 19, 37 and 61. The sequence grow by adding the multiples of 6 each time, like 6, 12, 18, 24. So we can reverse this idea to find the cube root of the perfect cube. Concept: to find the cube root of the perfect cube, we repeatedly subtract the term of the special sequence until the value becomes 0. So we will keep subtracting until the value becomes 0. The total number of subtraction tells us the cube root of the number. So step for the method. Step 1. Begin with the number whose cube root you want to determine. We will start with the number, subtract the first term of the sequence, hence which is 1. Then subtract the next terms, 7 from the result. Then continue subtracting the next term like 19, 37 and 61. Keep repeating this process. When you finally arrive at 0, so we have to keep subtracting until we get 0. The total number of subtraction performed gives the cube root. We will take an example here. Find the cube root of 216 using the repeated subtraction method. So the sequence will use 1, 7, 19, 37, 61, 91 like this. So we will keep subtracting 216 minus 1, 215. Then we will subtract 7, then 19, then 37 till we get 0. So how many times? 1, 2, 3, 4, 5, 6. So the cube root of 216 is 6. Next finding the cube root using prime factorization method. For large numbers, guessing the cube roots directly become difficult. If the number is large, it is very difficult to guess the cube root. In such case, the prime factorization method is reliable and systematic way to determine the cube root of the perfect. This method works because every perfect cube can be broken down into a group of 3 identical prime factors. Now steps to find the cube root using prime factorization method. Step 1. Break the given numbers into its prime factors. This means expressing it as the product of the smallest prime number. Clear? Step 2. Arrange all the identical prime factors into sets of 3. Sets of 3 are called triplets. The number of the perfect only if every prime factor can be grouped into complete 3 triplets. Step 3. Form each triplet, select one factor, we multiply selected factor together, the product given the cube root of the original number. Example, find the cube root of 512. First we will do the prime factorization. This is the prime factorization. Then we will make the group of 3. So, 1 group, 2 group and 3 group. From each group we will take one number. So, 2 into 2 into 2, that is 8. So, cube root of 512, that is equals to 8. Clear? Practice all the examples given here. Next, sole example. The volume of cubical box is given 0.027 meter cube. Find the length of the edge of the box. So, length of the edge of box, that is the cube of volume. So, we will find the cube, we will remove the decimal and 1000 in the denominator. So, that is equals to 3 by 10 meter. Hence, the length of each edge of the cubical box is 0.3 meter. Next is learning point 1.4, practice all the questions. Summary. Here is the summary of the chapter. The square number is the product of the number multiplied by itself. The perfect square always ends with 0, 1, 4, 5, 6 or 9. The square root of number is the value that when multiplied by itself gives the number. Square root can be found using prime factorization, repeated subtraction or estimation method. The number has an odd number of factors if and only if it is the perfect square. Pattern of square includes sum of the first n odd number, that is equals to n square. Now, the cubic number is the product of the number multiplied by itself 3 times. A cubic number is the product of the number multiplied by its 3 times. The cube of an odd number is always odd and cube of even number is always even. Perfect cube follow the pattern. A cube is the sum of the consecutive odd numbers starting from n multiplied by n minus 1 plus 1. The cube of the negative numbers is always negative because the negative multiply to the negative. Cube roots can be found using prime factorization and repeated subtraction using the special sequence, that is 1, 7, 19, 37 and 61. Every perfect cube can be expressed as the product of 3 identical factors. Cube root are useful in the real life problem involving volume and cubes. Square roots and cube roots help us to solving geometry, algebra and measurement problem. Understanding squares and cube build a strong foundation for higher mathematics such as polynomial, algebraic identities and mensuration. So student, here we end the chapter. In this chapter we have learned about the square numbers, cube numbers, square root, cube root, how to find out different methods, the pattern, all this we have learned in this chapter. I hope all these things are clear to you. Now to practice this.